Welcome back, everybody. We're going to get into a new topic, and we're going to talk about identity. Identity matters, especially as we're in this new world, this internet of value. Let's bring up our expert, Georg, to tell us why and how the blockchain is a solution, and how it's one that is sustainable, one that can make an impact, not just on you, but on your heirs. Let's give them a round of applause and bring them up now. Georg, welcome to the stage.
Thank you. All right, so my name is Georg, and I will talk to you about how I believe identity is actually perhaps the most important application on the internet.
Real quick.
Does this work? Yes, it does. So, when they built the internet, they somehow forgot to put in the identity layer. That, of course, is a bit of a quip, and it's not quite true because the internet actually, when they built it, right, it evolved over time in a way that at first it didn't seem to be an issue, and when it became an issue, people were like, oh damn, what do we do now to fix this thing? Because this was never supposed to be this big with these many, open participants. We can no longer control who has computers. When we built a lot of those protocols, IBM was still making predictions for, the market for computers globally being 10. Right? So obviously there's a few more than those even in this room right now. But what this means is that on the internet, as this famous New Yorker comic says, right, nobody knows your dog. And nobody knows who you actually are. Nobody knows what organization you represent, which device you are now for the Internet of Things, right? And who owns that device, what that device can actually do or should be able to do. All these things are very, very hard to put on afterward. But that's kind of what we're doing, we'll see. Why is identity such a problem? Well, hello? I think the battery is weak on this thing. Here we go. The internet today is everywhere, right? It is literally everywhere around us. We all have internet devices in our homes now. At least most of us do. We have smart TVs and home assistants and things that we talk to, and they're all connected to our identity. They all have a connection to our identity, and they know so much about us that basically they sometimes even know us better than we know ourselves. And they certainly know us better than almost anyone we know, and where we control what we want to share with other people. So the internet is literally everywhere. And the way that we approach this today, and this is today's model, this is what we do right now, is called a federated identity model, right? So a large identity pool owned by a certain entity. Those entities are, in particular, of course, Apple, Amazon, Google, Microsoft, right? They own that identity. And in those huge identity silos, we actually don't control them, right? We don't own them, we have no control over them, and the federated identity model is crucial to enable things like the surveillance economy, right? We know like Facebook and Google in particular, but they're not the only ones. And so the surveillance economy is only possible because of a federated identity model. The Social Dilemma is a very good movie in case you haven't seen it yet. I would recommend to actually have a look at it. It's definitely worth looking because it kind of gives you an idea of what that actually means, what that translates to. But even just from a purely economic viewpoint, is this a sane and safe model to run the world? When you create a huge pool of information, there will always be someone that is willing to somehow get to that information. And the bigger the pool, the more valuable the pool, the more effort you can expend as an attacker to get to the information, and it's still very much worth doing it. And I mean, that information today is billions, right? And we have records breached every year, and not just a few. I mean, these are just some of the bigger numbers that are publicly known, right? There's a lot we don't know. So we have data breaches everywhere because of the model we have today. And of course, then the whole login with, right? Login with Google, login with Facebook. It means every time you're going anywhere, you're telling that company that you're logging in with, I am here now and I do this with this party. Every time. And they get to approve you. They get to say, yes, this person is allowed to do that. And sometimes they do say no, right? I mean, in a way, today you can become stateless online. There's a very interesting case of someone who used Google as a login for virtually everything and then took a picture of their own child in the bathtub or something, or at the beach or whatever, right? Only for private use, right? No intention of sharing it anywhere, just a family picture. But there was a small child on there, right? So the AI flagged this as child porn and said, okay, you're deplatformed, that's it. And suddenly they could no longer log in at work. Right? That's the level of control they have over us today. And federated identity is that approach. So that's what we do right now. Can I have the next slide? There we go. Self-sovereign identity is what we believe is the future. That is what we should have, what we deserve. We work with decentralized identifiers, right? They are generated locally on the user's device, right? On your phone, on your laptop, wherever you are. They're locally maintained. The local device maintains the keys to the identity. They're fully decentralized in the way they work. And they have privacy by design. The entire approach to self-sovereign identity, the entire way that we have designed and built that system is actually with privacy and security by design. And this is not us alone, right? Vereign is a company in this field, but there is many companies in this field, including very large ones. And the standards, the open standards and the open source that this is all built upon are built together in the W3C, the Decentralized Identity Foundation. There's a lot of code in the Linux Foundation, in projects like Gaia X, all of this open source. So it's about building an ecosystem on a new approach to create the very first native identity layer. That's basically what SSI is and means. The key aspect of verifiable credentials is that you have a wallet. You can have multiple wallets, but very typically you have one wallet, and that wallet holds so-called verifiable credentials, which are basically digital documents signed that contain certain information about you or a device or an object that actually have been signed and verified by a third party that says, yes, this information is true. That is actually a true statement about this particular holder. They can be used privately and securely. When you use your SSI, you can choose to share what information to share with someone else. And the use cases are near infinite. I mean, login, of course, right? But data sharing of any kind, signing contracts. The adoption of this is coming fast, and faster perhaps than most people realize. Because not only did Switzerland have a referendum that struck down a federated centralized identity model and is now moving toward an SSI EID, so the official electronic identity of Switzerland will be issued based on that approach. In the EU, you have Gaia X, which contains virtually all the large European companies, which is focused on building a self-sovereign cloud for Europe. It's based on SSI. The EU is revising the EIDAS framework, which is for trust services online, for digital signatures online, to incorporate that approach of SSI. So you actually have adoption at a level that most people don't yet even realize it is there. And you have companies, even Microsoft, that now says we officially support verifiable credentials in production. So Vereign as a company, I mean, when I want to tell you what do we do, right? We do this, right? We build the technology and we support the transition from the federated to the SSI model of identity, right? That is what we do. And in fact, we've just built a stack for Gaia X, the Gaia X Federation Services component, where we actually have a complete stack for organizational participation in the SSI world. So you can connect any organization now, including doing things like organizational policies, evolving the trust services underneath, right? Universally resolving all verifiable credentials that are incoming and issuing new ones of your own. We have that stack now. That's one of the things we do, right? So we're kind of like a red hat in this field, like very early, very tiny still, but that's basically where we come at this, right? We want to build open source technologies built on open standards to enable that kind of ecosystem. Just very quickly, because I got the request to also include a little bit of how does this actually work. I'll promise I won't go too deep, but this is schematically how it works, right? So you have the issuer of verifiable credentials, right? This can be a government issuing an electronic identity, but this can also be a university issuing a student ID or a degree, a certification. It can be an access right to something, right? It can be even an ownership claim in principle. I mean, anything gets easily modeled into a verifiable credential. They store, when they issue the claim to the holder, right? They store, along with the ID of the issuer, the fact that they've created that credential, they store that against a blockchain, ideally. I mean, in theory, you can do this all with one centralized oracle down here for trust, but personally, I think that's not a great improvement over the current. I mean, it's an improvement, but not as great as we should have it. Because this actually allows us to build this as a purely decentralized system. Now, when they issue that credential to the holder, and the holder, by the way, can be a person, of course, but it can also be an organization. It can be a device. It could be a car, a plane, or an Internet of Things thing, right? Your TV even can be a holder of a credential. It can be, like, this can be anything, really, that interacts on the internet, right? So now the holder has the credential. When they want to use it, right, with someone, and that someone is the verifier tells the holder, all right, I see you want to do something with me. Here's what I need to know from you. So you see they want my name maybe, or my ID card, or whatever they want information, right? Depending on the use case. And then you see what information the other side requests from you, and you can say yes or no. So you know what is being shared every time. You can control it. And when they get that information here, they can now process it, they can use it, right, for the purpose that is defined. And they can go to the blockchain to say, all right, so that credential, does it really exist? Yes, I find it. It actually existed. It was issued. That issuer, can I find them? Yes, I can verify their credential chain down. So it's basically like Terry Pratchett said, it's turtles all the way down. In the SSI world, it's DIDs all the way down. So you can actually verify the entire chain and make sure this whole thing is legit. What is beautiful about this is the issuer has no idea where you went with that credential or who you spoke to, what data you shared, right? They don't get a phone home thing as they do in the centralized federated model. So there's an enormous benefit to this. And while the details in this are, of course, as in any such system, complex, the principle, I think, is not. And that's also very important because I think it's important we all understand what the principle is and should be, and that is what we want to build. Now, I believe, actually, and that's why I think, it is really the most valuable use case there, that we can use self-sovereign identity virtually all the things, because it is very hard to come up with use cases that do not somewhere, in some way, shape, or form, contain identity. At least identity in the sense of the acting party is the party that is supposed to be acting, right? Whether it's a device or a company or a person, doesn't really matter. So that's why SSI is actually, I believe, and that's obviously why I'm doing it, the most important thing someone can be working on right now. I believe it's the most valuable and most interesting thing to do, which is why I think SSI for all the things. That is what we should have. So where to start? Well, I thought I'd give you something very concrete and very simple. We've built a simplified, verifiable data credential powered by Eternity. And you'll find me afterwards actually up at the Eternity booth, right like in the main hall. So I'll be there in case you want to discuss some more. But basically, we've built this as a way to integrate it into email, where now you have email that contains the sender, it contains the information of where it went, it contains the actual information in the email, including all the attachments anchored against the blockchain, with a self-verification app that is decentralized. It's actually issued over IPFS as well as the information is being stored in IPFS. And it can do many, many things, but I'm at the end of my time, so basically, I thank you for your attention, and I hope I'll see you upstairs, and we will have the ability to have a chat. Otherwise, if we can't hook up, please, contact us, get in touch. You'll find me, I hope. And yes, let's build that SSI world together. Thank you. Exit stage left. We have a question.
I think everybody's had that experience where you open, an app for your vacuum cleaner and it asks for your location and your accelerometer and your Wi-Fi and the whole shebang. What is going to stop self-sovereign identity users in the future, companies, from just asking for your life history, and poor non-tech savvy users giving their life history to these currently federating companies?
That's a very good question. Nothing is going to stop them from asking, I guess, except, of course, data protection law. So under data protection law, if you're living in a region of the world where that's actually being taken serious, and Europe tends to be one of those, right? More or less, but much better than in other parts of the world, it is actually illegal to ask for more information than you require. So when that happens, there can be a Max Schrems, for instance, right, who says, why does my vacuum cleaner need to know my social security number, right? Why? And then, that person can say, well, wait a minute, there's a problem here, and the company will need to justify why they need the social security number in order to actually vacuum your room. That, of course, is a process that depends on regulatory work. It depends upon user behavior. It depends on all these things, right? I'm not saying SSI will magically solve all problems of the world immediately, but it is a system on which we can actually rely to build the world that solves these, because we have an identity system that actually works and scales, independent of any individual central party.
A follow-up question. Just one solution to that would be to selectively prove with a CKB, with zero knowledge proof,
Yes.
exactly what you want, without even disclosing your name.
True.
Applications, have you thought about in that direction?
Yes, of course. I skipped it for this because as an introductory thing, I thought it went too deep. But basically, there is this magical thing. It's hard to describe it any other way than magic, but with zero knowledge proof, you can prove things about yourself without disclosing the information itself. So you can, for instance, prove, I am a Swiss citizen, but you don't know who I am. Or I have a certain age. Or I have an entitlement from this university, but you don't get to know what is my student ID. So zero knowledge proof it works with homomorphic encryption typically, right? And encryption is already hard to explain, right? And so it's much harder to explain how zero knowledge proof works. There's only a few people in the world who actually understand it at the mathematical level. However, yes, with zero knowledge proof, we can then prove things about ourselves without needing to disclose them. So in a situation where you need, the usual example is you need to go buy a beer or whatever, and the store gets to ask you, are you 18? But they don't know anything else about you, right? There's several other use cases that you can think of where that would be true, right? You want to be able to prove you're a citizen of the country, or you're a alumni from this university, or whatever, right? There's multiple cases that you could imagine where you can build up use cases around this where you would want that ability to selectively obfuscate details about yourself while still proving the aspect that the other party is interested in. That, of course, is only possible in this kind of approach, right? Otherwise, you always have a third-party intermediary that does the obfuscation for you, which is a problem. I mean, then you have, again, one centralized middleman that knows what you're going to do and what you're up to. So SSI is the way to get there. Zero-knowledge proof is kind of like SSI plus, in a way, right? It's like the even better thing that we want to get to, but first we need to actually get SSI widely spread, I think. Yes?
Thank you for protecting our freedom, because I believe that freedom is a progress for humanity. Thank you.
Well, thank you. I mean, I agree.
Just an understanding question. So I guess your solution, because it's conceptually decentralized, so your decentralized identities can be only as good as the security you apply to your wallet. If your wallet gets compromised, what happens? Can you spend some words there around that? Because this is one of the issues, for instance, of decentralized, fully decentralized stock exchange, where you have everything in your wallet. And if you lose your wallet, what happens? You can reconstruct it via your original ID, but what happens to whatever transaction you already started with your existing wallet?
Okay, so first of all, yes, you're moving the security to the wallet to a very large extent. That is true. It is a progress in many ways because when you think of a classic security model with adversary and the party that is being attacked, right? It's always about how do I secure this asset so much that the cost of compromising it is higher than the value of the asset stored, right? And which is why the big centralized databases are just such juicy targets, because if I compromise them, I get billions of records, right? If I compromise your phone, I only get your records. That's a huge difference already in the sense of how hard it is to hack the system in the first place. Secondly, the system fails much more gracefully. So assuming I hack your phone, right? Yes, if I hack your phone and your phone does not have a security hardware chip in it, right, that somehow links this to things like your biometric ID or whatever phones use these days, or PIN, or yes, if the phone is fully compromised all the way down to the chip level, then your wallet is also fully compromised. That is true. However, given the use cases that we use for phones today, including things like online banking, and we have lots of things stored in our phones today, and the phones are not great in security, but they're not that bad. I mean, depends on how paranoid you want to be. You can get a security hardened phone even, right, if that's your real concern. And at the end of the day, what you're then talking about is, okay, so I've lost this one wallet, right? And we've built a POC actually a few years ago to try some of those concepts. And in this POC, what we did is we had an audit log for every single interaction that your wallet does that you can see on a second device. So if the wallet got compromised, you would know. And you can shut it off immediately. And then if you want to recover your wallet, we actually have had a social recovery process, because personally, I'm not a fan of these, like, you write down magic words and then you need to store them because you've just moved your problem to how can I keep those magic words secure, right? And it's an optimization problem. As a physicist, I think you cannot solve, because the number is always wrong, right? You don't want infinite copies because everyone who has a copy becomes you. But you also want enough copies that if you ever need them, you still find one, right? And that's, optimization-wise, is very hard to solve. And lots of people in the field have not been able to solve it, as you know from early adopters and even developers who screwed that up, right? So I believe social recovery is much better, where you split recovery keys using Shamir secret sharing or something like that, and you give them to, like in pieces, in fragments, to people that you have decided to trust for that recovery process. And then, I mean, we've built this into our POC. It actually worked really well. So I can say, these 5 people I trust enough, I need at least 3 of them to recover my wallet. And so now, once you've set up that connection with them, once they got their key fragment, none of them can by themselves recover your wallet, right? Every single one of them cannot do that step. But when you have the problem, you just give them we had to build this with a small 6-digit code, right? You give them the 6-digit code over a channel that you normally use with them, right? The phone, you meet them in person, whatever. And then they enter that into their dashboard, and poof, you have your key again, right? That, I think, is a much more human-friendly approach to solving this, because it makes sure that you get to decide whom you trust enough to be your trustee in that situation. And it's much better than the write down magic words and then hopefully no one else gets their hand on them, and hopefully you still have them when you need them. I actually believe that is the way we need to go. So we've built that into our POC. We will want to build that into our wallets as well for the end users. We haven't finished that part yet. We have a wallet, the personal wallet for SSI, but we haven't gotten to that layer yet. But I hope we get there.
How is the solution that you built with Eternity? So how does it work? How can I do it by myself if I want?
Well, I mean, you can go today to gitlab.com/Gaia-X, and there you find the Gaia X Federation services, and you go to the organization credential manager. That's the part that issues credentials and verifies them, right? It's a single shell command, actually. It starts up 5 or 6 containers on your local machine, and you have an OCM. It's all Apache 2 license, so you can do with it whatever you want, or you can contact us and we can help you, or you can say, oh, this would be nifty, or I want to build that, and then you contact us and we figure out how to build it best, and maybe we help you or whatever. I mean, let's work on that, but you can run this today. I mean,
what is the cost behind it, or it's completely free?
No, it's Apache 2 license, open source. I mean, there is no upfront cost for you. Of course, it is a specialist domain, right? It is complex technology, so most people right now don't have the knowledge to run this, which, is kind of unavoidable when you build something this fundamentally new. However, there's companies like us who are happy to help, but you don't have to pick us, you can pick someone else as well. Well, thank you. Thank you very much.